National Mathematics Day, 22nd December. India celebrates National Mathematics Day to commemorate the birth anniversary of Indian mathematical genius Srinivasa Ramanujan to his substantial contribution to the world of mathematics. To enhance the significance of this special day, let us have some glimpses on famous mathematicians from ancient to modern India. The first in the list is Vidyalaya, Indian mathematician who born around 800 BC. He was a Vedic Brahmin priest. He is said to be the original founder of Pythagoras theorem. His notable works are Approximation of Square Roots of 2 and Statement of the Version of Pythagoras theorem, and he knows the value of pi, and he have the idea of circling of squares. Next we are having Katyayana. Katyayana born around 300 BC. Notable works are Vatikakara, Vyakarana and later Subhasutra. Subhasutra was a document which contains earlier Indian mathematics. Vatikara was a grammatic book which is used nearly for 12 centuries, following 12 centuries for the students. Next is Pingala. Pingala was a musicologist and he was a linguistic, and he is very much interested in mathematics, and he translated Sanskrit poet mathematically in his book Chandrahasta. He knows binary numerical system, Pascal's triangle, binomial theorem, Fibonacci number, and etc. This binary numerical system now we are using 0 and 1 actually for the computer science and all. Okay. So, next person is Varahamihira. He lived around 6th century, and his notable works was Panchasiddhantika and etc. He was an astrologist, and he knows about the Pascal's triangle, and in the 6th century itself he knows the mathematical square, 4x4 mathematical square. Okay, so next is Yadivarshabha. He lived around 6th century. Actually, he was a Jain mathematician, and who gives a description of the universe, which is historically important in understanding Jain science and mathematics. He knows the measuring of distances, given the measuring of units of measuring distances and times, and he had the idea about the. Next is Bhaskara II. He born around 1114 Common Era. He is known for his principal discoveries on differential calculus in the astronomical problems and computations. It is believed that Bhaskara II knows the now existing Newton's laws and all his ideas on calculus and all.
An equation means nothing to me unless it expresses a thought of God. These words were spoken by the magnificent mathematician Srinivasa Ramanujan, whose contributions to the analytical theory of numbers has proved crucial to mathematical understanding. Srinivasa Ramanujan was one of the world's greatest mathematicians. His life story, with its humble and difficult beginnings, went through numerous hurdles, and ultimately, through trials of poverty and dedicated hardship, his work impressed G.H. Hardy, and he got in the University of Cambridge in 1913. Ramanujan is known for many significant anecdotes and contributions to math. Ramanujan's knowledge of mathematics, most of which he had worked out for himself, was startling. Some of his contributions are: in his notebooks, Ramanujan wrote down 17 ways to represent 1 by pi as an infinite series. He also worked on the divergence series. He found out 120 theorems to imply divisibility properties of the partition function. Goldbach's conjecture is one of the most important illustrations of Ramanujan's contributions towards the proof of the conjecture. The statement is that every even integer greater than 2 is the sum of 2 primes. Ramanujan and his associates had shown that every large integer could be written as the sum of at most 4 numbers. Partition of whole numbers is another similar problem that captured Ramanujan's attention. Subsequently, Ramanujan developed a formula for the partition of any number, which can be made to yield the required result by a series of successive approximations. Ramanujan also showed how to solve cubic equations in 1902, and he went on to find his own method to solve the quadratic. The following year, not knowing that the quintic could not be solved by radicals, he tried and of course failed. By 1904, Ramanujan had begun to undertake deep research. He investigated the series 1 by n and calculated Euler's constant to 15 decimal places. He also worked on hypergeometric series and investigated relations between integrals and series. He was to discover later that he had been studying elliptic functions. Ramanujan's own works on partial sums and products of hypergeometric series have led to major development in the topic. Now, about Ramanujan's number. In a famous anecdote, Hardy took a cab to visit Ramanujan. When he got there, he told Ramanujan that the cab's number 1729 was rather a dull one. Ramanujan said, "No, it is a very interesting number. It is the smallest number expressible as the sum of two cubes in two different ways. That is, 1729 is equal to 1 cube plus 12 cube, or 9 cube plus 10 cube. This number is now called the Hardy-Ramanujan number, and the smallest numbers that can be expressed as the sum of two cubes in n different ways have been dubbed as taxicab numbers. The next number in the sequence, the smallest number that can be expressed as the sum of two cubes in three different ways, is 87539,319. Unfortunately, Ramanujan had developed tuberculosis and had died at a young age of 32. But he had made pivotal contributions to mathematics, even with the short life he had lived. One of the greatest inspirations that Ramanujan gives us is that it's possible to make progress on your own through your natural curiosity. And I, for one, hope that many more people will take advantage of the tools we have today to follow Ramanujan's lead and make great discoveries in experimental mathematics. That is the greatest tribute we can give to this astounding man. Thank you.
We brush 2 times a day. Wow, my patti is circle in shape. I love juice 200 ml. I'm playing with the Rubik's Cube. It's a 3D shape. Good night. It's 10 o'clock.
Hello, a warm welcome to everyone. Do you know that maths is everywhere? Yes, today I am going to tell about maths in our daily life. Hope you all like it. Then let's go to the video. Okay friends, this is how fast maths in our daily life. Do you see a cage behind me? It has rectangles, squares and line segments. Who is inside the cage? of food we give to him and shape of the food is also maths. You can see a house behind me? It also have maps. It has triangle, rectangle, squares and line sequence. Ouch! What's this? Boards. It also have maps. Number of boards and its shape circle.
India has given a lot to the world of mathematics. This is the day of the birth anniversary of the great Indian mathematician Chinmaya Ramanujan, who took the world of mathematics by a start at a very small age. The seeds from Ramanujan's garden have been blooming and have been sprouting all over the landscapes. These are the words said by the great famous mathematician Freeman Dyson about Srinivasa Ramanujan. Ramanujan has made many fundamental contributions to the field of number theory, infinite series, continued fractions, number analysis, etc. Mathematics is defined as the science which deals with the logic of shape, quantity, and arrangement. Mathematics is a part of our lives. Whenever we go somewhere, whatever we do, we are using maths daily without even realizing it. It comes naturally. Mathematics is a universal language in that it is a language understood in all countries. Hi everyone, keep calm, it's math day. We are Jnana, Jwala, Jwaliya from 5A. Today we talk to you about the influence of mathematics in our daily life. Mathematics is the cradle of all creations without which the world cannot move an inch. Be it a cook, or a farmer, or a carpenter, or a mechanic, or a doctor, or an engineer, or a scientist, everyone needs mathematics in their day-to-day life. Even insects use mathematics in their everyday life for existence. Snails make their shells, spiders design their webs, and bees build their hexagon combs. There are countless examples of mathematical patterns in nature's fabric. We always encounter numbers in our everyday life. We are using them in adding, subtracting, multiplying and dividing our payments or expenses. Sports and games are very important in our healthy life. We think mathematical geometry are applied in sports ground. Make a basket of basketball's ground. Run around the track or time of hitting a ball. We use knowledge of maths during cooking time. For example, it is very common to use a half or double of a recipe. In this case, we use proportions and ratios to make correct calculation for each ingredient. So, we know that mathematics makes our life orderly and prevents chaos. Certain qualities that are nurtured by mathematics are power of reasoning, creativity, abstract or spatial thinking, critical thinking ability, and problem solving ability. Finally, our mistakes must be immediately corrected without any criticism. So, keep calm. Math is always with us.
Hello, and good morning to one and all. Today is National Mathematics Day or Ramanujan Day. Maths, the unlimited true fact. This is a story of a girl who completely changed her vision towards maths. There once lived a girl. She always hated maths and she often said, "What subject is this? Only filled with those symbols like plus, minus, into. What? I don't like it at all. It is so boring."
Math is awesome. Now, let's see some of the example pictures for the topic Maths in our daily life. Some people aren't even out of bed before encountering math. Setting an alarm and hitting snooze, they may quickly need to calculate the new time they'll arise. Or they might step on a bathroom scale and decide that they'll skip those extra calories at lunch. Many, if not all, puzzles and games require mathematical logic and deduction. This section uses the fun and excitement of various popular games and puzzles and the exhilaration of solving them to attract and engage the visitors to realize the mathematics in fun and games. In store, whether buying coffee or a car, basic principles of math are in play. Purchasing decisions require some understanding of budgets and the cost and affordability of items from groceries to houses. School and work. Students can't avoid math. Most take it every day. However, even in history and English classes, they may need to know a little math. Whether looking at time expanses of decades, centuries, or eras, or calculating how they'll bring that B in English to an A, they will need some basic math skills. Waiting in a line. What buttons do you touch to make 56? Which candy is shaped like a cylinder? How many forks do we need on the table for everyone to eat? These all are very simple examples for math is everywhere in our daily life.
The chronology of Indian mathematicians spans from the Indus Valley civilization and the Vedas to modern India. Did you know that India added zero to maths? So let's see some famous Indian mathematicians and their contributions. Aryabhatta, who lived from 476 to 550 CE, is the first of the major mathematicians from the classical age. His chief work was the Aryabhatiya. He worked on the place value system and was regarded as the first to use zero in the place value system. He correctly calculated the areas of triangle and circle. He also worked on the approximation of pi and may have come to the conclusion that pi is irrational. Aryabhatta also gave tables to science. In algebra, he gave general solutions to linear indeterminate equations. Brahmagupta, his chief mathematical work is the Brahmasputra Siddhanta. He was the first to formulate the concept of zero and negative numbers. Brahmagupta correctly calculated the volume of a cube and the approximation for pi. He also gave rules for working with positive and negative numbers. Brahmagupta introduced the formula for cyclic quadrilaterals and methods of finding the square roots and cube roots of numbers. Bhaskara II. His chief work in mathematics was Leelavadi. He was the one who declared that any number divided by zero is infinity. His most important mathematical contribution is the representation of numbers in a positional system. Bhaskara was the first to write numbers in the Hindu decimal system with a circle for zero. He gave a unique and remarkable rational approximation of the sine function. Satyendranath Bose was born in Calcutta as the eldest of 7 children. He was a famous physicist specializing in theoretical physics. He is best known for his work on quantum mechanics with Albert Einstein in developing the foundation of the famous Bose-Einstein statistics. The class of particles that obey Bose-Einstein statistics, bosons, were named after him. He served on many research and development committees in sovereign India. Kalyambudi Radhakrishnan Rao, or famously known as C.R. Rao, is an Indian American mathematician and a statistician born in 1920s. He is known as the living legend. His major contributions are the estimation theory and functional equations, statistical inference and linear models, multivariate analysis and combinatory design, orthogonal arrays and biometry, statistical genetics and generalized matrix inverses. Thank you.
Hi and good morning to everyone. Today we are going to do a game to a conversation by Ashwati and Aparna. Now let's see what are they discussing about. Over to them.
Hi Ashwati, what are you doing?
Hi Abarna, I'm playing magical game with coins.
Oh, can you please explain the game to me?
Of course, here there are 10 coins in circle and 5 coins in vertical. You have to start from the vertical line of coins and enter into the circle and count in clockwise direction. You can repeat the circle multiple times till you are counting. Once you stop counting, you don't need to tell the number, but you can start counting in anti-clockwise direction. Should be the same.
Can you please explain it with an example?
Sure, for example, you start from vertical line, count till 11 and stop there. After that, from the same point where you stop, start counting 11 in anti-clockwise. Did you understand now?
Yes, that's an interesting game. Now can I try that?
Let's start. Tell me when you are counting in anti-clockwise direction and tell me nothing about the number.
Yes, I finished.
Is this coin where you stop counting?
Yes, it's right. How did you get it?
Let us assume as x the number of points in the particular line. That will be a variable. We can put any number of points there. Coins in circle is static, which is of value 10. So during anti-clockwise direction counting, it will become x plus 10 itself, which means you will stop at fifth coin from the adjoining point of vertical line and the circle.
Now it seems way simpler than before.
Yes, if you know maths behind it, it's a simple game. Otherwise, it's a magic.
Thank you Ashwati and Aparna for demonstrating this game and hope all of you enjoyed this engaging game. Thank you.
Application of mathematics in astronomy. Astronomy in mathematics. Everything in this universe is connected with mathematics. Everything including art, engineering, medical science, and even astronomy. Let's see how astronomy is connected with mathematics. Astronomers use math all the time. One way it is used is when the camera, specifically a charged coupled device, detector that is attached to the telescope basically converts or counts photons or electrons and records a series of numbers. Those numbers might correspond to how much light different objects in the sky are emitting, what type of light, etc. In order to be able to understand the information that these numbers contain, we need to use math and statistics to interpret them. We look at objects in the sky with a telescope. An initial use of mathematics in astronomy is counting entities, sources, or objects in the sky. Objects may be counted during the day, time, or night. Math is used in astronomy to calculate routes for satellites, rockets, and space probes. In addition, math is used in global positioning system for transmitting messages when data is compressed and for coding the images and element modeling to build spacecraft. As a modern example, astronauts use math to direct a space shuttle that moves at a speed of 17,500 miles per hour to a space station for a rendezvous. Complex mathematical calculations must be performed so that the two objects moving at a high speed can meet at one point without causing damage to each other. Geometry is used in astronomy to determine the properties of stars and other objects in space. It is developed to be practical guide in measuring the velocity, area, volume, and length of heavenly bodies. Astronomy is a study of these objects, and geometry assists in figuring out their scope and placement in the firmament. Trigonometry is used to measure the distance to stars in the solar system and the motion of nearby stars compared to more distant stars. The method of measuring distance in space is called trigonometric parallax. Numbers and units like kilograms are used to show the weight, mass, radius, etc. of planets, stars, satellites, meteors, etc. The great ancient astronomer Aryabhatta used mathematics to prove his astronomical statements. Mathematics is wonderful. We saw how mathematics is applied in astronomy. After reading those points, we can conclude that mathematics is amazing. Thank you.
Number as your soul number. If you wanna live your life on high, then work hard. Remember, 1, 2, 3, 4, natural number as you become soul number. If you wanna live your life on high, then work hard. Remember.
No need to be like Ramanujan, neither be like Euler. You must be unique in the world that your name would become so familiar. 1, 2, 3 are natural numbers. Add 0, it become whole number. If you wanna lift your life on high, then work hard. Remember.
Add more love of God in your life like addition. Multiply your knowledge like a multiplication. Add more love of God in your life like addition. Multiply your knowledge like a multiplication. Divide sorrow, separate sadness from your life. Divide sorrow, separate sadness from your life.
Where is the end of maths? I searched everywhere and found that infinite's the end of the maths. Then I am astonished. Where is the end of maths? I searched everywhere and found that infinite's the end of the maths. Then I am astonished.
No need to be like Ramanujan, neither like Vidyalaya. You must be unique in the world that your name will be so familiar. 1, 2, 3, 4 are natural numbers. At 0, it becomes whole number. If you wanna lift your life on high, then work hard. Remember.
So now let's see how mathematics is involved in chemistry. One good example for that is suppose a scientist is making an experiment of mixing two chemicals together, and you should only take 40 milliliters of chemical A and you should only take 30 milliliters of chemical B. If you exceed that limit and if you mix that together, there will be a huge explosion. Suppose like that. So, how do we calculate the exact amount of this chemical A and chemical B? By using mathematics. And also in balancing of equations of chemical reaction, we use mathematics for counting the different number of molecules in those both chemicals. And mathematics is not only in chemistry, it is there in all branches of science, such as in physics. The formula for speed is distance divided by time. How do you calculate the answer for that? By using maths. And this is what makes maths a unique subject. It is fun, it is interesting, and it is very useful in our life. Thank you.
Maths in finance. When we deposit our money in bank for some scheme, we think of how much interest we get from that scheme by calculating the interest. And we will compare it with other schemes available, and then only we come to a decision to take which scheme. In this scenario, we use maths for calculating the interest and to compare them also.
Mathematics is an important part of managing business. Business mathematics is used by commercial enterprises to record and manage business operations. Commercial organizations use mathematics in accounting, inventory management, marketing, sales forecasting, and financial analysis. Taxation is a term for when a taxing authority, usually a government, levies or imposes a tax. The term taxation applies to all types of involuntary levies, from income to capital gains to estate taxes. Bill, a printed or written statement of the money owed for goods or services. Various bill, electricity bill, water supply bill, gas supply bill.
Maths Day 2020. Discoveries of Ramanujan. Book and movies about Srinivasa Ramanujan. There are many books about Srinivasa Ramanujan, among which a few are: Srinivasa Ramanujan, Biography, Srinivasa Ramanujan, Friend of Numbers, Ramanujan's Notebooks, The Man Who Knew Infinity, A Tale of the Genius Ramanujan, Number Theory and the Spirit of Ramanujan. Ramanujan is a 2014 biographical film based on the life of Srinivasa Ramanujan. It was shot back-to-back in the Tamil and English languages. Some major discoveries by Ramanujan.
Mach modular form. In mathematics, a Mach modular form is the holomorphic part of a harmonic weak Mass form, and a Mach theta function is essentially a Mach modular form of weight half. The first examples of Mach theta functions were described by Srinivasa Ramanujan in his last 1920 letter to G. H. Hardy.
Srinivasa Ramanujan and G. H. Hardy.
A Mach modular form will be defined as the holomorphic part of a harmonic weak Mass form. Fix a weight k, usually with 2k integral. Fix a subgroup gamma of SL2Z, or of the metaplectic group if k is half integral, and a character rho of gamma. A modular form F for this character and this group gamma transforms under elements of gamma by. A weak Mass form of weight k is a continuous function on the upper half plane that transforms like a modular form of weight 2 minus k and is an eigenfunction of the weight k Laplacian operator, and is called harmonic if its eigenvalue is 1 minus k by 2, into k by 2, Bruin-de-Ramp, Funkit 2004. This is the eigenvalue of holomorphic weight k modular forms, so these are all examples of harmonic weak Mass forms. A Mass form is a weak Mass form that decreases rapidly at cusps, so a harmonic weak Mass form is annihilated by the differential operator. If F is any harmonic weak Mass form, then the function g given by is holomorphic and transforms like a modular form of weight k, though it may not be holomorphic at cusps. If we can find any other function g' with the same image g, then f minus g' will be holomorphic. Such a function is given by inverting the differential operator by integration. For example, we can define where is essentially the incomplete gamma function. The integral converges whenever g has a zero at the cusp I, and the incomplete gamma function can be extended by analytic continuation, so this formula can be used to define the holomorphic part g' of f even in the case when g is meromorphic at I, though this requires some care if k is 1 or not integral or if n equals 0. The inverse of the differential operator is far from unique as we can add any homomorphic function to g' without affecting its image, and as a result the function g' need not be invariant under the group gamma. The function h equals f minus g' is called the holomorphic part of f. Ramanujan's nested radical. In algebra, a nested radical is a radical expression, one containing a square root sign, cube root sign, etc., that contains, nests, another radical expression. Example, 3 equals root 1 plus 2 root 1 plus 3 root 1 plus 4. Proof. Define f of x equals x plus n plus a, so that f of x raised to 2 equals x plus n plus a raised to 2 plus xf into x plus f. Set a equals 0 n equals 1 x equals 2 and substitute recursively for f of x. Goldbach's conjecture. Goldbach's conjecture is one of the oldest and best-known unsolved problems in number theory and all of mathematics. It is one of the most important illustrations of Ramanujan. The statement is every even integer greater than 2 is the sum of two primes. That is 6 equals 3 plus 3. Ramanujan and his associates had showed that every large integer could be written as the sum of at most 4. Example. 43 equals 2 plus 5 plus 17 plus 19. Ramanujan-Nagel equation. In mathematics, a field is a set on which addition, subtraction, multiplication, and division are defined and behave as the corresponding operations on rational and real numbers do. A field is thus a fundamental algebraic structure which is widely used in algebra, number theory, and many other areas of mathematics. The best known fields are the field of rational numbers, the field of real numbers and the field of complex numbers. Many other fields, such as fields of rational functions, algebraic function fields, algebraic number fields, and p-adic fields are commonly used and studied in mathematics, particularly in number theory and algebraic geometry. Most cryptographic protocols rely on finite fields, i.e., fields with finitely many elements. The relation of two fields is expressed by the notion of a field extension. Galois theory, initiated by Évariste Galois in the 1830s, is devoted to understanding the symmetries of field extensions. Among other results, this theory shows that angle trisection and squaring the circle cannot be done with a compass and straight edge. Moreover, it shows that quadratic equations are algebraically unsolvable. Fields serve as foundational notions in several mathematical domains. This includes different branches of mathematical analysis, which are based on fields with additional structure. Basic theorems in analysis hinge on the structural properties of the field of real numbers. Most importantly for algebraic purposes, any field may be used as the scalars for a vector space, which is the standard general context for linear algebra. Number fields, the siblings of the field of rational numbers, are studied in depth in number theory. Function fields can help describe properties of geometric objects.
So these were some of the many discoveries made by Sir Srinivasa Ramanujan. Thank you.
Hari Om and good morning, my dear children. Today is special. It's National Mathematics Day. Mathematics is here to show you the way. Children, keep saying, Mathematics, I love you dear. That is the best cue to get rid of all your fear. Mathematics is our close friend in need. It teaches us life's calculations. That is great indeed. The plus, the minus, the division, the multiplication. Teach us that life is a grand celebration. Children, mathematics is our constant companion, reminding us always to be a true Indian. The lines, the squares, The circles, the triangles, all teach us to look at life's myriad angles. Mathematics teaches us to adopt the right attitude so that we can reach easily a high altitude. We see mathematics in all walks of life, teaching us and giving us everything in a life. Learning mathematics is great fun. It gives great joy to everyone. Mathematics is a fascinating game. Let's play it. Bit by bit, we shall reach the summit. Happy learning. Hari Om and thank you.